Hi everyone, I am Sneha from Web3 Compass and this is day 6 of 30 days of building with Solidity. For everyone who is not aware about this campaign, head over to day 1 video. That is where I talk about the campaign in detail. You can also go to the website web3compass.xyz to get all the relevant information. This is our challenge page, and for every day we have one smart contract that we are writing. And this is day 6. Okay, so let's get started. So as of now, we've already built an auction system where users could place bids. We've created a treasure chest that only an admin could unlock, and we've learned how to track balances, restrict access using modifiers, putting in conditions basically on who can perform a certain function. But let's be real. So far, we've been playing with toy money. It's just numbers stored on the blockchain. But what if we wanted to build something a little more practical, something a little more real, right? So let's say you and a few close friends want to create a shared savings pool, a digital piggy bank, not open to the public, just your own little club, probably for your next travel plan. So everyone should be able to join the group if approved, deposit savings, check their balance, and maybe even withdraw when they need it, right? And the best part, eventually this piggy bank will be able to accept real ETH. So now again, ETH or Ether is the native currency of Ethereum blockchain. And since we are building on top of Ethereum, or like right now we're not, but Solidity is the programming language that is supported by Ethereum blockchain. So we're going to talk a lot about in terms of ETH. So yeah, let's start building, right? So with EtherPiggyBank.sol, the concepts that we're going to master, again, we've already talked about message.sender, address data type, Ether balance, and deposit and withdrawal functions, and how we need to use keywords like payable to be able to actually transfer some real ETH. As an example application, we're saying that let's make a digital piggy bank. Users can deposit and withdraw Ether. You learn how to manage balances using address to identify users and track who sent Ether using message.sender. It's like a very simple bank account on the blockchain, demonstrating how to handle Ether and user addresses. So just let's get started. I'll head over to Remix Ethereum IDE and just create my file. It says Ether Piggy Bank .sol, right? We'll just copy the first 2 lines from here. Again, you should type it so that you have practice. Oh, why did again? My bad. Yes. So we say, okay, contract, Ether Piggy Bank. Yeah. So, okay. Now, for this piggy bank, what is it that we would need, right? We always start with what are the kind of variables that we need here, or what is the data that we're actually looking to store, and how to migrate through the function. So we will talk about these building blocks one by one. So before we start writing functions, let's think about how are we going to design the entire system. So for piggy bank, let's first think of who would be in charge of this piggy bank. If you're talking about a normal bank, there's a bank manager who takes care of all the accounts that are a part of it. So here also we would like our piggy bank to have a bank manager. Just like every group would need a leader who takes care of things, and someone very responsible who would do functions like adding new members and all of that. So we'll introduce a bank manager for whom we would need to store their wallet address. So we'll use the address data type and we'll say, hey, address public bank manager. Cool. Very easy. So this is the person who will actually be deploying the contract and setting up the entire piggy bank. They're the one with admin privileges basically, and the only one who can approve new members in the club, right? Now, who are the members that we're going to talk about, right? We might just have a group of 10 friends. We might have 5 friends. So we need to store all of their wallet addresses and check if they're going to be members. So what we'll do is that we'll do an array of addresses for these members. My God, AI giving me a hard time. So we say, hey, address members, and then we have to check if these members are already a part of our bank. That is why we'll go forward with mapping. Again, if you're not really aware of what mapping is and how are we writing everything, head over to our previous videos. We have talked about all of these new concepts in a very detailed manner and used it in implementation. We basically implemented everything while we talk about it. So yeah, you should go watch that video. If not, let's just continue again. So we have initialized a bank manager. We have an array of members, and we have a mapping which is mapped from address to a Boolean value, checking if a particular member is a registered member or not, right? So okay, now what? How much has each person saved? Obviously, they would need to know that. So we would need another mapping which would map their wallet address to a uint value, and that's going to talk about their balance, right? So we just write balance. Now again, we're not mentioning public because it does not have to be accessible by everyone. So yeah, it's on you. If you want everyone else to know about your balance, you can just keep it public. People can from outside can also see. And now, cool. I think that is all the variables that I can think of at the moment. So let's just go forward. Okay. Now I know that while I'm trying to thinking of creating a bank account and setting up a bank manager and admin privileges, I need to set up a few things. So what I will do is that in order to creating a different function for it, I would just call the constructor, which I know that is going to run only once when the smart contract is deployed. And I will say that, hey, you know what? When this is deployed, I want the bank manager. Um, oops. Okay, we don't need this. Please ignore AI here. Yes. And I'll say, hey, let's just set it as like whosoever is the message dot sender, let's just set it as, bank manager, and we don't need this as well. And something that we would want to do as well is that we don't have to separately add the bank manager as a registered member. So since we have created a list of members, right, we will say that, hey, we just need to push it in that particular array and say that, oh, by default, this bank manager is already a member of that bank. So we will write members dot push message dot sender. Okay. So I hope everyone's, pretty clear on this part. Now, okay, now we need some rules, right? We know that, maybe if I want to perform a function like adding a particular member to a bank, right? I want only the bank manager to do it. And instead of repeating it again and again in the functions, I would say let's create a modifier that's going to check. And I will say that, okay, let's say, okay, modifier is called only bank manager. And what does it do? It says, first, there is a requirement that is going to be like, okay, this condition that we're talking about, that require bank manager equals to message dot sender, or the opposite, like message dot sender equals to bank manager. And it says, whenever we're going to use this, right, we're going to say that only the bank manager can perform this action, so that if someone else is trying to do this, they get this message and they know that, hey, you know what, you're not the bank manager. So we'll say, okay, we'll write error messages like something that gives us a clear idea of what went wrong. So only bank manager can perform this action. Okay. And since we've talked about the modifiers in the previous section, we know that this underscore is basically once this criteria is checked, and in whatever function that we are checking this is basically that we enter the function block, and this is the particular line that will run first. And if it goes through, then this underscore tells that, hey, you know what, you can proceed with the rest of the function implementation. If not, that means this particular condition has failed and it will return an error value. Okay. Now, fine, we're done with one modifier. Now what next? Okay, so we know that in this case, if someone else tries to do a particular operation which should be done only by the bank manager, then that person will get a message like only bank manager can perform this action. That means we have restricted the admin facilities here. Okay. Now, another thing that I will show you is that while writing the code, there is a condition that we're going to check again and again, right? That is this particular person who is calling this smart contract a registered member? Now, every function that you have to write, you need to implement that or mention that condition that I want to deposit. So the contract will first check if I'm a member of the bank to be able to deposit, right? And then I want to withdraw. So again, the bank will check, oh, is she a member of the bank to be able to deposit from her account? So what we'll do is that instead of that repetitive implementation, we'll again create a modifier just like we did previously, and we'll just call it that, right? So we'll say, okay, modifier only registered member, right? And it says, oh, what is it supposed to check? It is supposed to check that, just like AI suggests, that, hey, required members message dot sender, and you say, oh, if this works, then fine, proceed. Otherwise, say member is not registered. Okay, so then if I'm not a registered member of the bank, I cannot really go about depositing or withdrawing any money, right? So now we have our roles, memory, everything in place, and it's time that we implement actual features. Those actual features are actually just function implementations that we're talking about, right? So the first thing that we would want to do is that add members, right? Because that is very important. Right now, the bank manager is the only person who is part of the bank. So I'll compile this and show you that, oh, everything compiled. Nice. Now, this is the account address that we're talking about. But what I'll do is that I'll just I'll just save a few addresses here so that I don't have to, migrate and change it again and again. This is again sample addresses that we're going to use later. And in my previous videos, I had to do a lot of to and fro, change, perform functions. So I'll just save it here. You can also do it as a sample thing, and I'll go back here because this is the account address that I will deploy from. So let's deploy it here. Okay, it went through. Now, right now, we only have these two things. One is this address thing, registered members, right? This is the mapping that we're talking about. And then we'll say, okay, what is the bank manager? Okay, nice. And registered member. So there are no registered members currently that we're talking about. And since we have not made the mapping public, that is why that particular mapping is not visible here. But for this mapping, we made it public. That is why it is visible here. And then everyone could just, check. So if I paste this address, okay, and call it, okay, because we have not set up any values, by default it is taking the false value. That is what we have for a Boolean value. But yeah, let's skip that. We'll implement that later. So you should remember, and only when you compile and deploy and you see the output of certain things, you know that what is it that needs to be corrected. Okay. So now we're going to write the function add member, and we have to remember that, hey, you know what, we have to make sure that this particular function is only to be done by the bank manager. So what is it that we're going to pass, right? We're going to pass an address, right, for the member, and check a few conditions. Okay, now I'll tell you what those conditions are, but this is how we actually implement a modifier. Okay, so it says, okay, function public only bank manager, great. Now the first thing that we will check is that the address that, whosoever is the member that we're talking about, or address that has been provided, it's not, equals to address 0. Now, 0 address is basically a sample, or it's just 0x000. It does not really exist. And in case you're transferring any Ether or anything to that, performing a transaction with it, all of that money will be lost, right? So it says that it does not have to be equals to address 0. If not, great. Otherwise, you say, hey, you know what? This is an invalid address. Okay. So you have to check for that nobody is giving a 0 address. Then you will say that since we're going to add members and the bank manager is already a member of the bank, we will check that the member's address, member not equals to message dot sender. This is the first time when the deployment happens, right? So we say, okay, bank manager is already a member. Okay, because we're taking it by default, we've already pushed it. And then the other thing is that suppose I have forgotten that I already signed up for the bank, so I am doing it twice, right? So I'll say, hey, you know what? Also check that the registered members in the registered members list that we have, registered members, member, okay, there is no such member that is existing, right? Otherwise you will say, okay, member is already registered. Okay, great. So these are the conditions that we wanted. Once we have surpassed all of these conditions, we'll just say that we need to add this particular member to, to the mapping. So we'll say, hey, you know what, this is the registered members mapping. So we will just set it to true. Okay. And it would say members dot push member. Okay. Members is this particular list, and then we'll push the member in that. Okay. So this add, okay. So bank manager, we already have it, and I will just use this demo address. I'll paste it here, add members, and then I'll check for this, and it says, oh, bool true. Okay, great. So now that we have added that, we've added all the members, we'll say, what if I want to like quickly view the member? Now this is not very important to add, but it's nice to just be able to see how many of you have like actually registered. Again, this is going to be a very quick function because we're not giving any parameters. We just want to return value. So everybody knows that we're going to say public view returns. And what is the data type that we are expecting? It's going to be address, but we have declared it as array list. So, that is why it's going to be a list of array, and we're always using memory with it and say, hey, return members, please don't look at this. And then, yeah, that's it, right? So get members would be a very quick thing. Now, now that we have added members, we've also gotten the list of these members. We say, hey, you know what? I really, really want to deposit the money. Now, this particular function has to be restricted that only registered members are going to deposit the money, right? So I will say, okay, function. Um, function deposit amount. Okay. Function deposit amount. Again, what is it that we are passing? UN256 underscore amount, right? And what is it? What is the modifier that we are going to use? Only registered member, right? So that is why we have written it initially, because we have to check that the person is a registered member. So we say only registered member. Now it is very simple for you to just check that, okay, require amount has to be greater than 0. Definitely, right? If yes, please proceed. If no, just let the person know that, hey, you know what, this is invalid amount. Come on, let's not joke around it. And we say, okay, the balance mapping that we have done, what we're going to do is that say, hey, balance for that particular message dot sender has to be a plus equals to underscore amount, right? Now, if you want, you can just write it also like balance message dot sender equals to, again, same thing, copy this plus amount, like this as well. But yeah, this is like a more optimized version. Sorry, underscore amount. But yeah, okay. So we've done deposit amount. Great. So it is basically checking that it's greater than 0 and you are a registered member, right? But the problem with this particular deposit function is that we're not really dealing with real ETH. Okay, we didn't do anything different. We're just going to provide a number, and that's going to be reflected as a deposit amount. Okay, it's just like a prototype where we are testing that. Oh, how is it that it's going to look like? So what we'll do is that okay, let's just do one thing. Let's just compile and deploy it and let you know that what is it that I'm talking about. Again, I will copy this contract address, wallet address, and I'll do add member. So in the get member, you see the bank manager and you see the new person. Now in the deposit amount, I'll say, hey, you know what, let's add 2, okay? And you say, oh, member is not registered. What happened again? Oh, sorry. It was for the bank manager. Yeah, I say deposit amount and it goes through and it says get members, but then we're not actually able to see the value, right? Because we've not written a function around it. But yeah, let's just implement it. Now again, you've seen that there is an issue here that it says when I was trying to add the amount from the bank manager's account, it said, oh, member is not registered. Why? Because although we've put a condition here that bank manager is already a member and I've done like members.push message.sender, I didn't really add it as true, right? So if you still check the bank manager's address, it would be a false. So that is something that you need to fix here, and we'll do it, but later. Right now, we look at how we're going to implement the necessary function, show you the difference in withdraw amount, also write a get balance function. Again, it's suggesting a get balance function, so I'll just quickly write this. Now okay, we've written the get balance. We do not like AI again. AI, yes. Public view returns, okay, balance message dot sender. You can also be like, hey, you know what? This is not exactly how we're going to write it. We're going to like check again if this is not like a oops. zero address that we are talking about, because we'll be dealing with real money, and it is very important that we actually specify it. Although in this code we've still not implemented that, but we're going to write it, right? So we'll just say, hey, let's just be as careful as we can, and oh, we're talking about a particular member here, sorry. Not just provide address, because not just anyone can check the balance, right? You have to be very careful on who is checking the balance. So we say, okay, return and then balance of that particular member. Okay, let's delete this, compile it again, deploy it. Okay, I deployed it from the wrong address. So this time I'll use this particular one. I'll say, hey, you know what, add member. Okay, it went through. Get members again, the first deployment and the other account. Now I want to deposit amount too. So I'll say, okay, member is not registered. Sorry, again, we're using the bank manager's wallet address, a condition to fix, but that's on you. You should fix it, right? Because I've told you the other criteria that we're talking about. And this is the account that we have set. So yeah, this is how we'll go for deposit amount. And then for this particular person, I'll provide the address and say, hey, get balance, and here it is, 2, right? But again, did we talk about ETH? Did anything happen to the value here? No. Why? Because this is just a random function that we're talking about. So we'll say that, listen, let's just implement something called as function deposit ether. Okay, deposit ether. Now this is going to be exactly same as the previous deposit function that we have written. We'll provide an amount. We'll say, okay, public modifier only registered members. Okay, member. And again, I'll just quickly copy paste this. Okay, the amount has to be greater than 0. What else? That if yeah, and there will be a change here. Okay, so now what happens in the case of Ether is that we're saying two things. First, what we missed out here is that this has to be a payable function. That is one change that we have to be implement, where we say, when we are declaring a function to be payable, that means this function is allowed to receive Ether. Okay, without it, any ETH that you have sent would be rejected. Second is that we can't really write it as balance message dot sender plus equals to amount. It will use something called as balance message dot sender plus equals to message dot value. Okay, now what is message dot value? It holds the amount, okay, of ETH in way that user sent it. Now again, oh yeah, oh shit, sorry, I actually wrote it in here, but I should have written it here. So you saw, right? If you want to use message.value, that particular function has to be payable. Now here, if you see way, gue, fini, ether, so you will see that actually 1 ether, okay, is equals to 10 to the power 18 way, right? I'll show you. Convert way to ether. So that's a smaller denomination that we are talking about. How much is 1 way of ether? So it's 10 to the power, 1 ether is 10 to the power 18. Again, how much is 1 gue, whatever way it is that we pronounce. So, okay, whatever this is, 3, 3, 6, 7, 8, 9. Yeah. So it's like half, so it's 10 to the power 9. 1 gue would be 10 to the power 9 sorry, 1 ether would be 10 to the power 9 GUI. So yeah, this is how we're going to write it. Now what we'll do is we'll let both the functions be, okay? So whenever a member is calling this function, it will include ether in the transaction, and we'll show how differently does it actually act. Right? So we've done deposit amount, we've done deposit ether, we've done a get balance. Now what is left? Obviously, if you're adding money, you would want to take it out as well, right? So we'll just quickly write the last function, that is function withdraw. Again, very cute little function which says, okay, you in 256, again, amount. What difference are we doing? Public. The modifier would be again only a registered member. Sorry, not registered. It would be registered member. Okay, great. So what is it that it is going to check? So again, same thing. This is definitely a criteria that amount has to be greater than 0. But when we're talking about withdrawing, we're also saying that, hey, you can only withdraw the amount that you have. You cannot withdraw higher than that. And just like AI suggests, that balance message.sender has to be greater than equals to amount. If yes, great, let's go forward. Otherwise, it's insufficient funds. And then with whatever that you're using, it says balance message.sender minus equals to amount. Great. So we've been able to write this. Now let's quickly just stick here, compile all of this. Great. It is compiled, so no issues as of now. We'll shift this a little here and say, hey, you know what? Let's deploy. Great. So we're adding add members. Okay, great. So this is 1. This is oops, I don't know what is wrong. This is the another one. Okay, get members. So we'll have 3 addresses here. Now, deposit amount is this function that we're talking about, right? So I'll say, hey, you know what? Let's just add 2. And actually, which account is it that we want to check for, right? So this is the account. So I'll also say, first, let's check what is the balance for this particular amount. By default, it will be 0. That is how all of it is initialized. And then I'll say, hey, let's deposit amount and then check get balance. Okay, great, 2. Now deposit ether. Okay. Deposit ether. Okay, we did something wrong here. Actually, when it's taking message.value, it is not supposed to specify the amount here. Since we copied it from this function, that is the mistake that we have done. Oh, shucks. Now we'll have to change this as well. Message.value. Now, why do we have to do this? It's because, you'll see here, all of these are in ethers, okay? The dummy money that we're talking about. So with message.value, that particular value is actually taken into consideration. That is why the user cannot specify it from outside. And this is the value that it will take, okay? So we'll have to quickly compile it again. I am so sorry for missing that important thing out. Okay. So that is how we've deployed it. Again, we'll add member. Okay, sorry. We have to deploy it, right? We have to deploy it first. So let's see. Okay. So we have deployed it from this account. Okay. So this person is the bank manager. Okay. Now let's quickly just add this member and get the balance of it. Okay. Get balance of it. It's 0. Now I'll deposit amount. Okay. Deposit amount. Oh, change it here, deposit amount. Yeah, okay. Get balance too. Please make sure that you're not making these mistakes while doing, the transaction. Sometimes you will get errors and you'll be like, hey, what did I do wrong? And then you will realize that, oh, I forgot to change the wallet address. Okay. Now for deposit ether, I'll show you what happens. Right now, it's in way, right? Way is the smallest unit that we're talking about. So I'll say, hey, you know what? I want to give out 10 way. We are on the right account. So I'll say deposit Ether. It went through. Now let's check what is the balance. 12. That's because even when we're talking about amount, it is taking it in somewhere in way. Okay. But now I'll say, here the balance upgraded. Now it's after 18 decimal places that we're able to see like 0.00001 ETH. So I'll say, hey, you know what? I can't see the difference here. So let me just switch to Ether and say, I want to give out 10 or maybe 15 Ether. Okay, right now the balance is 99.999 and I want to deposit that much. So I'll say, hey, deposit Ether. And now I'll say, oh, get balance. And you'll see it's 15.00000 whatever decimal places one ETH because we directly talked about 15 ETH, right? And from here, this account, it's subtracted, right? Why? Because this is how the transaction is happening. You're depositing it from this account to your account. Now, with withdraw function, I'll say, okay, I want to withdraw like 10. Okay, withdraw 10. Let's go. And now get balance. So with 10, what is the value that it's actually taking? It's taking it in way, right? It's not taking from message dot value. So nothing actually changes here. But if we change it to message dot value, just like we did for this one, you'll be able to see the difference that we're talking about here, right? But that's on you to play around. I hope the concepts are clear here. Please feel free to ask any questions that we have. And just for a quick wrap up, we're saying that in this session, we've built a savings club or a piggy bank with very clear roles, bank manager and members, a registration system for new members, a balance tracker for deposit and withdrawals. We played around Ether, some real money, saw how exactly things are happening, and then, the ability to accept real Ether into the piggy bank and all of that. Again, we've already seen a few possible implementations that you can do. First, that change the bank manager's status to true. Otherwise, it's not considering it as a added member. Maybe add a withdrawal function that sends Ether back to the users. Right now, we're just dealing with the amount. Maybe add limits, approval systems. Okay, that is it supposed to go through an approval of the bank manager that a person can withdraw and whatsoever. So yeah, let's just keep building and I will see you for day 7. Okay, bye.